Hello student, how are you? I am Arun sir. Welcome to my channel Tuition Expert. Today in this class I will teach you the relative velocity. Student, if you watch my video regularly and follow my class attentively, I can assure you that you must crack the NEET exam confidently with a good rank. Welcome to my NEET crash course series. Today's class is relative velocity. Now let's start about the class. Relative velocity. What is first define relative velocity? Okay. Suppose two body moves with velocity v and vb along same direction. Now what is VAB? VAB means relative velocity of A with respect to B. VAB means velocity of A with respect to B. So simple definition is VA minus VB. First we have to memorize, we have to learn this definition strictly. Now VAB equal to VA minus VB. So this is a vector quantity, magnitude of VAB equal to VA minus VB. So this is actual definition. Now, so what is VAB? VAB equal to VA minus VB into I vector. So magnitude of VAB equal to VA minus VB. So when two body moves along same direction, then actual, that is relative velocity, will be difference of the magnitude of two velocity. Now remember this definition. Then VA into I vector minus VB into I vector, that is negative vector, minus. So this is VA plus VB into I vector. Now VAB magnitude equal to now VA plus VB. So when two body moves in opposite direction, then relative velocity of one with respect to other increases. Now if two body moves along perpendicular direction or at different direction, suppose a man moves with velocity Vm along this direction and rain fall vertically downward with velocity this. So what is the velocity of rain with respect to man? What is the velocity of rain with respect to man, or at which direction rain comes? So to calculate VRM, that is we observe that is man observe velocity of rain with respect to him. So VRM equal to VR minus VM. Now VR is along this direction and VM minus VM, that is this is VM. So we have to, if this is VM, then minus VM is this direction. So VR minus VM means along this direction. So if the rain comes, the rain actually comes along this direction. This is angle theta. Now we can measure the angle theta. And what is the VRM? VRM equal to root over VR square plus VM square. Okay. So this is the velocity of rain with respect to man. Now, if we want to measure the angle theta, then tan theta equal to VR by VM. So theta equal to this. So if you are asked that what is the angle at which the umbrella should be held to protect the rain, now that angle is theta, that is theta with horizontal direction. Theta, two roads are at an angle theta, and one car moves with this road, one car moves along this road, the car A, and another car B moves along this road. Now what is the velocity of B with respect to A? That is, if a man at the car A observe the car B, then at which direction car B appears to the man A, at which direction car B appears to the man A. Now for this, that is we have to measure VBA. VBA means VB minus VA. Okay. So VB is along this direction minus VA along this direction. Now this angle is pi minus theta. So if we draw the parallelogram, if we draw the parallelogram, then this is along, this is actually VBA, this is actually VBA, VB minus VA. So VBA magnitude will be root over VB square plus VA square plus 2 VB VA cos pi minus theta, which is equal to cos theta. So this is the answer. And if we have to measure this angle, this is actually pi minus theta. If we have to measure this angle, then we know tan alpha equal to VB sin this angle pi minus theta by VA plus VB cos pi minus theta. So this will be the angle alpha. Angle alpha is measured by this formula. This is the actually formula of parallelogram. If we draw this B, this is A, this is A, this is B, and what is the angle alpha? Alpha equal to this. We know that alpha equal to this. This is B, so this is B sin, and this angle is theta, B sin theta, and this is B cos theta. So tan alpha equal to perpendicular B sin theta by A plus, this is A plus B cos theta. So from this formula we can write this. Here angle between two vector VB and VA is pi minus theta, and VB is B, VA is A. So we can write this formula. Now you have board problem. So general theory of river port problem. I will first discuss general theory of river port problem. Then the special cases will be discussed. Okay. Now suppose this is river and VR, this is velocity of river, and suppose write the term here VBR. First VBR equal to velocity of boat with respect to river. VBR is velocity of boat with respect to river, or velocity of boatman. We can write velocity of boatman in still water. Now VR equal to velocity of river, and two case. Now what happens if VBR is along this direction at an angle theta? We consider this is at an angle theta. Now W equal to width of the river. W equal to width of river. So suppose if boatman starts from this point and he want to crosses the river, and he starts at an angle theta with the bank like this way, and velocity of VR river is this. So what happens here? Here the man can reach at this point or this point. So what is the component of this VBR? We resolve first VBR along two directions, this and this. So this is VBR cos theta, and this is along VBR. This is VBR sin theta, and this is VR. So if we take this is X and this is Y, so Vx resultant velocity of along X direction equal to VBR sin theta. Resultant velocity along X direction equal to VR minus VBR cos theta. Okay, so this is VR, this is VBR cos theta. So along X axis resultant velocity is equal to this, and along Y axis only one velocity present, this. So along Y axis velocity equal to VBR sin theta. These are two velocity. Now the boatman crosses the river with the velocity this. So time taken to T equal to time taken to cross the river equal to what? Width of the river divided by this velocity, because here we distance taken along this direction, distance is along this, so we have to take along this direction velocity, we have to take the velocity along this direction. So time equal to W width divided by this velocity, because W, that is width, is taken along this direction. So if we take the velocity along this direction, then we can calculate the time taken to cross the river W. So T equal to W by V VR sin theta. So this is the time taken. And if the man can reach here, so this is the x is called the drift. So here x equal to drift equal to velocity along x direction into time taken. So this would be this Vx equal to this into T. What is T? T equal to this. T equal to this W equal to root of the. So this is the general theory. We can find the drift and time taken to cross the river. This is the general theory. Now from this we can from this theory we can derive the special case. Now from this theory we can consider two special. Now special case is crossing of river in minimum time. First, crossing of river in minimum time. This. Now we derive time taken equal to this. So time taken will be minimum. Here consider time taken will be minimum if theta is variable, if sin theta is maximum. So time taken T is minimum when sin theta equal to 1. That is theta equal to 90 degrees. That is, if the man start perpendicular with the bank, then he reach the other bank at minimum time. He reach the other bank in minimum time. So to crossing of river in minimum time, when you are asked that crossing of river in minimum time, you draw the figure with this diagram. That is, first the man start with this. This is VR. This is VR. Now velocity of river is along this direction here. So actually the man reach at here. Now from the figure what is the drift and time taken? T equal to W by VBR. Here sin theta equal to 1. So time taken equal to this. W by VBR, and here drift equal to x equal to, what is x? X equal to this. When sin theta equal to 1, theta equal to 90 degree. So cos 90 equal to 0. So drift here will be Vx equal to VR minus cos 90 0. So VR into W by VBR. This is the drift. You can find this. This is VBR. This is VR. Now this velocity you can get. This velocity does not require. So you have to always measure the time taken and drift. So this is the special case when the man want to cross the river in minimum time. Now next case is crossing of river. Crossing of river at shortest path. Crossing of river at shortest path. So here, that is, the man should start at an angle theta. So this is VBR. This angle is theta. And velocity of river in this direction. So from this and this, the velocity will be in this direction. This is the resultant velocity VR. So here drift will be 0. Now if x and we take x, this is x, this is y. Now what is the velocity along x direction? X direction velocity was VR minus VBR VBR, cos theta, and y direction VBR, sin theta. So here the man want to cross the river at shortest path, that is depth will be 0. If the man want to cross the river just opposite to B, this will be the shortest path. So for shortest path actually depth x equal to 0. Now what is depth? Depth is velocity along x direction into time taken. Time taken was w by width by, this is width by ty, that is VBR sin theta. Now this equal to 0, depth equal to 0, that is this should not be 0, that is this equal to 0. So cos theta equal to VR by VBR. So from this we can get the angle theta. From this we can get the angle theta. So if the question is that what should be the angle at which the boat should direct it such that he cross the river at shortest path, or he can reach just opposite to that of A, then the angle theta, first we find the angle this with the help of this formula. Then if you write the answer, the angle with the direction of river, then the angle with the direction of river equal to pi minus theta. If we can find the angle theta, then we can measure the pi minus theta. So this theta can be measured with the formula this. Now there are many problems. First problem is a train is moving towards east direction. Train is moving towards east with a speed 25 meters per second. A person is running on the roof of the train with a speed 5 meters per second against the motion of train. Velocity of the person as seen by a observer on ground will be what? Velocity is a ground. A train is moving along this direction with velocity 25 and a person moves along opposite direction. This is 5. Velocity is this. Now here we don't have to take the relative velocity. A person on the ground see the man. The velocity of the person as seen by an observer on ground. This is observer and this is person. So here we have to take actual the velocity of the person, observed by the observer on the ground. Now the train is moving 25 meters per second. Suppose the train moves forward in 1 second 25 meters, and the person on the roof moves opposite direction 5 meters in 1 second. So actual movement of the man will be actual movement. What? Actual movement is 25 minus 5. That is 20. So 20 towards east. So the answer will be 20 meters per second towards east. Now if the train moves 25 meters in 1 second, the person moves 5 meters in opposite direction in 1 second. So actual movement will be 25 minus 5, that's 20. So here this is not the relative velocity of this person with respect to train. This is the velocity of the person observed by the man on the ground. So this is the answer. The next question is, a man wishes to swim across a river 0.5 kilometer wide. If he can swim at the rate of 2 km per hour in still water and the river flows at the rate of 1 km per hour, the angle made by the direction with respect to flow of the river along which he should swim so as to reach a point exactly opposite his starting point should be what? So here this actually the man, suppose here start from this point A and want to cross just opposite of A, that is at point B. Now he should start with this way. Now if this angle is theta and this velocity is what? This velocity we call VBR, and this is VR. So VBR. So here drift is 0, here drift, that is, if we take so this is velocity of river VBR. So now he want to cross just opposite of A, that is at point B. So drift will be 0. Now what is drift? To drift to be 0. So we have VBR cos theta equal to VR. If x equal to 0, then velocity along this direction will be 0. So VBR cos theta actually this direction velocity VBR cos theta. So this and this will be equal. This is equal to this, such that velocity along x direction equal to 0. So this equal to this. From this we get cos theta equal to here. Now what is VR? VR of 1 kilometer. So this is 1, and what is VBR? VBR is given 2. So half, that is theta equal to cos theta equal to half, means theta equal to 60 degree. Theta equal to 60 degree. Now would be this. So this is 60 degree. So this angle is 180 minus 60 degree, that is 120 degree. So this is the answer. 120 degree. This is the answer. Next problem is a boatman can row a boat to move with a speed of 10 km per hour in still water. River flows steadily at the rate of 5 km per hour and the width of the river is 2 km. If the boatman crosses the river along the minimum distance, here minimum distance is given, minimum distance of approach, then the time elapsed in moving the boat. So he want to cross in minimum along the minimum distance. Now the time taken to cross the river. So the figure is here like this way. Minimum distance means such that the man can reach at this point. So this is the crossing of the river along minimum distance. Now this is VBR, this is VR. So if we can measure this angle, then time taken T equal to actually VBR width divided by W equal to width divided by VBR sin theta. So this is the time taken. Now so here x equal to 0, that is drift 0. For drift 0, what now the velocity along this direction VBR cos theta will be equal to VBR cos theta equal to VR. Now if this velocity, that is component of, that is x equal to 0, means velocity along x direction is 0. Now what is the velocity along x direction? This is equal to VBR cos theta along this and VR along this. So this velocity will be equal to this. Okay, this velocity means component of this velocity along this direction should be equal to this, such that net velocity will be 0 along x direction. So from this we get cos theta equal to this by this. What is VR? VR is velocity of river. This is 5, and VBR means velocity of boat with respect to river. That is this velocity of boatman. This, that is 5 by 10, that is half. That is theta equal to 60 degree. Theta equal to 60 degree. Now what is time taken? Time taken equal to W width. Time taken equal to width. Width is what? Width is 2 km. 2 divided by VBR. What is VBR? Velocity of river. That is 10 sin 60 degree. This is VBR. VBR means velocity of boat with respect to river. That is boatman. This 10 sin 60 degree. That is sin 60 degree root over 3 by 2. That is this. This is the answer. 2 by 5 root 3. So this is the answer. This problem is a bird is flying towards south with a velocity this, and a train is moving with a velocity this towards east. What is the velocity of the bird with respect to observer of the train? Now, if suppose this is east, west, north, south. Now, here we have to measure velocity of bird with respect to train. So this is VB minus VT. So velocity of bird towards south. That is in this direction. This is velocity of bird. Now velocity of train along each direction. VB equal to what? 40. And train is moving with a velocity 40. So this is velocity of the train 40. Now VB minus VT. Actually VB minus VT. So minus VT is along this direction. This is minus VT. Now VB and minus VT resultant will be this. So magnitude will be VB square plus VT square, which is equal to 40 into root 2. 40 square plus 40 square this. Now the direction will be in this direction. So this is south, this is west. If this angle equal, so this angle is 45 degree, must be 45. This is 40, this is 40, 40 by 41, so theta equal 45 degree. Now this angle is 45 degree, that is 45 degree. So the direction is along southwest. So the answer will be southwest. This is the answer. Problem is two ships A and B are 10 km apart. Two ships A and B are 10 km apart on a line running south to north. Ship A further north is steaming west at 20 km per hour and ship B is steaming north at 20 km per hour. So if we draw the picture, then suppose this is ship B and this is A. This is not direction. Here the ship is A. VPA, distance of AB is given. What? Distance of AB is 10 km. What is the distance of closest approach? What is their distance of closest approach and how long do they take to reach it? 10 km apart. So A, here is ship A and here ship B. A is more northern to ship A is further north. So here is ship A and here is ship B. Distance between two ship is 10 km given, and the velocity of two ship VA equal to 20 km per hour each. 20 km per hour and VB equal to this. So two ships are given, velocity are given. Now what is their distance of closest velocity? So VB, direction of VB is along this. And direction of VA, that is velocity of ship A running south to north. Ship A further north is steaming west. So this direction of A is this direction and direction of B is along this direction. So what is the closest approach? What is the closest approach? Now if we measure the relative velocity, VBA, what is VBA? VBA equal to VB minus VA. So minus VA means that is we have to take this, we have to reverse the velocity of A. This is minus VA. Now VB and minus VA. So result is this. The magnitude of, suppose this is direction I and this is direction J. So this is actually VB equal to 20 J and 20 I. So magnitude of VBA will be root over 20 square plus 20 square, which is equal to 20 root 2. So we get the relative velocity of B with respect to A. Now for this type of problem we can assume that that A is at rest. A is at rest. So if the ship A is at rest, then the ship B can move. The ship B move with velocity VBA along this direction. So this direction of VBA will be what? Theta is tan theta equal to, if we take this is theta, tan theta equal to perpendicular by base. So this is 20 by 20, that is 1. So theta equal to 45 degree. So theta equal to 45 degree. Now this angle is 45 degree. So ship B moves with velocity VBA along this direction, which is 45 degree with horizontal. So ship B moves with this velocity along this line, and A is at rest. So what is the closest distance? The closest distance is perpendicular distance, that is this. This is the closest distance. So now this angle is 45 degree and this angle is 45 degree. So AB is 10. So we can measure the length AC. We can measure the length AC. So this is B, this is C. We can 90 degrees. So sine 45 degree equal to now for this we can sine 45 degree equal to, from this problem, sine 45 degree equal to perpendicular by hypotenuse. So here perpendicular equal to AC, hypotenuse equal to AB. This is base perpendicular by hypotenuse. Perpendicular is AC and hypotenuse is AB. So AC by 10. So AC equal to 10 by root 2. Now similarly BC equal to this, base by hypotenuse, BC also 10 by root 2. Now what is the time taken? Time taken equal to distance BC by velocity. The ship B moves with velocity VBA, whose magnitude is this. So VBA, that is BC equal to 10 by root 2 by VBA equal to 20 root 2. So this equal to 10 by 20 into 2, that is 1 by 4 hour, which is equal to 15 minute, which is equal to 15 minute. So this is the answer, 15 minute. So this is the answer. Now I once repeat the problem. Suppose first we find VBA, relative velocity of B with respect to A, VB and VA. Here this is the velocity of VA, VB. Now we can easily measure the relative velocity. If we assign a direction I and this is J, then we can assign this velocity. We can assign this. Now what is VBA? VBA equal to this. We can measure the relative velocity. Now to find the closest distance, let ship A is at rest, then the ship B moves with velocity VBA along this direction. So first find the direction. We get tan theta equal to perpendicular by base, that is theta equal to 45 degree. So this is 45 degree. So the car B moves along this direction. Now what is the closest distance? Closest distance equal to this perpendicular distance. So from the figure we get AC and also BC. Now the time taken is equal to distance BC divided by velocity of relative velocity of BA, that is 15 minutes. Next problem is a man can row a boat with 4 km per hour in still water. If he is crossing a river where the current is 2 km per hour, current means velocity of river, how long will it take to row 2 km up the stream and then back to his starting point, up the stream and then back to his starting point? So here from now if the river flows in this direction, then down the stream means this direction along the velocity of river along the velocity of current is the downstream. We call this term downstream. Means if a boatman moves along the direction of river, it is downstream, and upstream is when the boatman moves against the velocity of river. This is upstream. So if the problem is here, if VR equal to velocity of current and VB equal to velocity of boat, VBR equal to velocity, VBR we assign VBR velocity of boat with respect to river, or in still water velocity of boatman with in still water. Then of the velocity effective velocity of boatman, along downstream will be just add, if the two velocity direct in same direction, so effective velocity will be VBR plus VR, and velocity of boatman along upstream will be VBR minus VR. So here in downstream two velocity will be added and upstream two velocity will be subtracted. Now what is the time taken? Time taken equal to distance by velocity when the boatman moves along upstream. So their time taken will be this, more time, and when he moves along the downstream, so time taken equal to this. So this is the answer. VBR, now giving VBR equal to man can do in still water 4 minus 2 plus 2 by 4 plus 2. This is the answer. 1 plus hour. This is the answer. Crossing a river in a boat. If he crosses the river in minimum time, it takes 10 minutes with a depth 120 meter. If he crosses the river taking shortest path, it takes 12.5 minutes. Find width of the river, velocity of the boat with respect to water, whatever speed of the current. So we have to measure W, width of the river, VBR and VR. See, now here first things is a man crosses the river in a bit. If he crosses the river in a minimum time, so when he crosses the river in minimum time, minimum time means he should start with perpendicular, because we know the time equal to W by VBR. If VBR start with this angle, then cos theta sin theta, so theta sin theta, so theta will be 90 degree for minimum time. That is, T minimum will be when theta equal to 90 degree. We know T equal to W by VBR sin theta, so T minimum will be W by VBR when theta equal to 90 degree. Now here T minimum is giving, T minimum is 10 minutes, so 10 equal to width by VBR. Now here the depth is x equal to depth is along this direction. So what is the depth? Formula of depth is depth equal to, this is VBR, so along this direction this is VBR cos theta and this is VBR sin theta. So depth equal to velocity along x direction into time taken, so Vx equal to VR minus VBR cos theta into time taken here is 10. So depth equal to giving 120. So dip equal to 120, that is VR minus VBR cos theta. Cos theta will be here sin theta equal to 1, sin theta equal to 1, so cos theta equal to 0, sin theta and cos theta equal to 0. So this is VBR, only VBR into 10. So we get VR equal to 12. 120 meter, so meter per minute. So VR equal to this. Now the river in minute. Now if he crosses the river taking shortest path, for shortest path, what is the for shortest path? This figure will be this. So VBR, this is VR and this is VB, suppose velocity of boat VB. Now what is the relation between this? Here VB equal to, from figure we get VBR square minus VR square. So for shortest path the figure will be this. Velocity of boat, actual velocity of boat will be in this direction, such that he can cross just opposite of starting point. This will be the shortest path. So figure will be this way. Now from this figure we can write this. Now what is the now the time taken here, T equal to W by VB, which is equal to W by VB equal to this. Now T equal to what? T equal to 12.5. So 12.5 equal to, we get VR equal to this, and to W equal to 10 into VBR. Now again here 12 time equal to 12.5 equal to W equal to 10 into VBR by root over VBR square minus VR square. Now what is VR? We get VR equal to this. So this is 12 square. Now from this we get VBR. Velocity of boat with respect to VR we get. So if we get VBR, then we can also get the width of the river. So three question we get. So three answer we get: VR, width and VBR. So here we have to write first at minimum time, and then another condition is shortest path. Two condition we have to apply. So from this we get VBR. Student, this is the end of the class. To get such type of videos, subscribe my channel and welcome to my series NEET crash course. Okay, thank you.